Good morning, students. Today we are going to deal with Fourier series for discontinuous functions. So what we covered up to now is we defined Fourier series on general interval c2 c plus 2 pi, and we defined for different intervals like on 0 to 2 pi and minus pi to pi also. And we find the values of a0, an and bn. These a0, an, bn are called, what are they called? They are called coefficients of Fourier series, and the formulas are called Euler formulae. So by using Euler formulae we are find many problems finding a0, an and bn. And next we went to find Fourier series for different functions such like f of x is equal to x on 0 to 2 pi, f of x is equal to x square on 0 to 2 pi, f of x is equal to e power of x on 0 to 2 pi, f of x is equal to pi minus x on 0 to 2 pi. Like that we are able to cover as many problems as finding Fourier series on for many functions on interval 0 to 2 pi. That's what we covered up to now. So today we are going to cover Fourier series for discontinuous functions. How to find Fourier series for discontinuous functions? What are discontinuous? The question arises now. What is meant by discontinuous functions? The discontinuous functions are example. I will go for example. Before example, let me. So example is f of x is equal to 1 if 0 less than x less than pi, and 0 if pi less than x less than 2 pi. So from 0 to pi the function value is 1, and from pi to 2 pi the function value is 0. So left side of pi it is 1 and right side of pi it is 0. That's why such a functions are called discontinuous functions. These functions are called discontinuous functions. Let us move on to the next. Okay, so now let us do some problems. First problem is find the Fourier series of the function f of x given by f of x is equal to 1 if 0 less than x less than pi, and f of x is equal to 0 if pi less than x less than 2 pi. So 0 to pi the function is 1, and pi to 2 pi the function is 0. So this is a discontinuous function. For this discontinuous function, now we need to find Fourier series. What is a Fourier series? F of x is equal to a naught by 2 plus sigma an into cos nx plus sigma bn into sin nx. So this is a Fourier series. Already you know the Fourier series formula. What is that? F of x is equal to a naught by 2 plus sigma an into cos nx plus sigma bn into sin nx. So what is a naught here? A naught is equal to 1 by pi 0 to 2 integration 0 to 2 pi f of x dx. So it is from 0 to 2 pi. So, but what is f of x? F of x is defined from 0 to pi it is 1, and pi to 2 pi it is 0. So that's why divide the integral from 0 to pi and pi to 2 pi. So 1 by pi integration 0 to pi f of x into dx plus integration pi to 2 pi f of x into dx. From 0 to pi it is 1, and from pi to 2 pi it is 0. So the second integral what I have circled becomes 0. No need to calculate. Now what is 1 by pi? Integration of dx is x from 0 to pi. Upper limit minus of lower limit 1 by pi. Pi minus 0, 1 by pi into pi, this is 1. So a naught is equal to, what is a naught? You got 1. Are you able to get it? This is a Fourier series. F of x is equal to a naught by 2 plus sigma an into cos nx plus sigma bn into sin nx. Now we need to find a naught, an and bn. What is a naught value? 1 by pi integration 0 to 2 pi f of x into dx. But the function in 0 to 2 pi it is not same value. It is from 0 to pi it is 1, and pi to 2 pi it is 0. So you have to divide into two integrals. 0 to pi and pi to 2 pi. In 0 to 2 pi it is 0, so only find this 0 to pi integration dx means dx integration x upper limit minus lower limit, you got a naught is equal to g1, that is a naught. Now let us find an. An is equal to 1 by pi integration 0 to 2 pi f of x into cos nx dx. What is f of x? In 0 to 2 pi it is not same. 0 to pi it is 1 and pi to 2 pi it is 0. So divide the integral into two parts, that is 0 to pi and pi to 2 pi. In 0 to 2 pi it is 1 and pi to 2 pi it is 0. So this you cannot, no need to find. So integration of cos nx is sin nx by n upper limit minus of lower limit. Sin n pi always 0, sin 0, sin pi, sin 2 pi, sin 3 pi, sin 4 pi, sin 5 pi, all 0. So sin n pi is 0, already we written in the note. Many times I repeated, this is observation, sin of any multiple of pi is always 0. So sin n pi 0, sin 0 0, 0 minus 0 0, 1 by pi into 0 is 0. So an is equal to 0. That's all. An is equal to 0. This is what we got. Are you able to get it? An is equal to 0 to 2 pi f of x into cos nx dx. From the function f of x is defined from 0 to pi it is 1 and pi to 2 pi it is 0. So divide the integral 0 to pi into two integrals 0 to pi and pi to 2 pi and pi to 2 pi to 0. So no need to take this, only calculate this. Cos x integration sin x, cos nx integration sin nx by n upper limit minus of lower limit, that gives the answer an is equal to 0. Are you able to get it? So let us move on to, now we got what, first of all we find a naught is equal to 1 we got. Now we find an is equal to 0. Now let us find the bn value. Bn is equal to 1 by pi integration 0 to 2 pi f of x into cos nx, f of x into sin nx dx. So for an it is cos nx, for bn it is sin nx. So 1 by pi integration 0 to 2 pi f of x into sin nx dx. But the function is from 0 to pi f of x's value is 1 and pi to 2 pi the f of x value is 0. That's why divide the integral into two parts, that is 0 to pi and pi to 2 pi. So I am writing the integral from 0 to pi, it is 1 into sin nx dx plus pi to 2 pi 0 into cos nx dx. 0 into something 0. So the second integral you need not to take, this is 0, what I am circling is 0, no need to calculate. Now coming to the first integral, integration 0 to pi, 1 into sin x means sin x integration minus cos x. Sin ax integration minus cos ax by a. Here sin nx integration minus cos nx by n from 0 to pi. So 1 by n, minus 1 by n constant outside, so minus 1 by pi n constant cos nx from 0 to pi. Upper limit minus of lower limit. Cos 0, 1. Cos 2 pi, cos 4 pi, cos 6 pi, cos 8 pi, cos 10 pi, all are 1. Cos pi, cos 3 pi, cos 5 pi, cos 7 pi, all are minus 1. Therefore, in general, cos n pi is equal to minus 1 whole power of n. This formula already I told you in first class in basics only. So, sin n pi is always 0, whereas cos n pi is minus 1 whole power of n. Now, substitute upper limit cos n pi minus 1 whole power of n and cos 0 is 1. So minus into minus plus, if we multiply with minus, plus minus becomes plus and plus becomes minus. So answer is bn is equal to 1 by pi n 1 minus minus 1 whole power of n. So this is how we find bn. You see, you got the bn. So first of all what we did, So this is you have to find Fourier series for discontinuous function. First we find a naught value. A naught is equal to what we got. A naught is equal to. So wait for. Yes, shall I start? Yes, you can start now. So a naught we got 1 and an we got 0 and bn we got 1 by pi n into 1 minus 1 whole power of n. Now substitute these values to find Fourier series. Fourier series f of x is equal to a naught by 2 plus sigma an into cos n x plus sigma bn into sin n x. A naught value 1 and an value is 0, so this term becomes 0. So 1 by 2 minus sigma minus 1 whole power of n minus 1 by n into sin n x minus, if you multiply with minus 1 by 2 plus 1 by pi sigma 1 minus 1 whole power of n into sin n x. Now substitute n is equal to 1 to infinity. N is equal to 1, n is equal to 2, it becomes 0. For n is equal to 3, 1 by 3 sin 3x. For n is equal to 4, it is 0. For n is equal to 5, 1 by 5 sin 5x. For n is equal to 6, it becomes 0. So for all even n values, it is 0. So after substituting the values, we get f of x is equal to 1 by 2 plus 2 by pi into sin x plus 1 by 3 sin 3x plus 1 by 5 sin 5x and so on. Are you able to get it? Here you are substituting a naught and bn values, but an value is 0. That's why the middle term is 0. A naught is equal to 1 and bn term you are substituting. Substitute n is equal to 1 to infinity. You will get the answer. So this is a naught we got 1, an we got 0, bn we got 1 by pi n into 1 minus 1 whole power of n. After substituting we got Fourier series f of x is equal to 1 by 2 plus 2 by pi into sin x plus 1 by 3 sin 3x plus 1 by 5 sin 5x and so on. Now let us go to the second problem. Find the Fourier series for f of x. F of x is equal to minus k when minus pi less than x less than 0 and k when 0 less than x less than pi. So this is the function. From minus pi to 0, the function value is minus k, and 0 to pi, the function value is k. Now it is defined from minus pi to pi. So what are the interval? Interval is minus pi to pi. Now you have to find Fourier series on minus pi to pi. Remember, the function is discontinuous function. From minus pi to 0, it is defined as minus k, and 0 to pi, it is defined as a k. Not like the previous problem. In previous problem it is 0 in half interval and 1 in another half, but here minus k and k, so you need to find both the integrals. So now you see Fourier series f of x is equal to a naught by 2 plus sigma an into cos n x plus sigma bn into sin n x. So what is a naught value, an value and bn value? You have to find a naught, an and bn value by using Euler's formulae. So what is a naught? A naught is equal to 1 by pi integration minus pi to pi. Why minus pi to pi? The interval is starts with minus pi, end with pi. Therefore it is 1 by pi integration minus pi to pi f of x into dx. But what is f of x value? F of x value is from minus pi to 0, it is minus k, and 0 to pi, it is k. So now divide the integration minus pi to pi from minus pi to 0 and 0 to pi. Minus pi to 0, you have to write minus k, and 0 to pi, you have to write k. So minus k or k or both are constants outside of integration. Dx integration is x, x minus pi to 0, and in second integral dx integration is x from 0 to pi, upper limit minus lower limit. What's the answer? 1 by pi minus k pi plus k pi minus k plus k pi cancel, a naught is equal to 0. Are you getting this? Minus and plus cancel, therefore a naught value is 0 you will get. So this is how we find, now you are able to find a naught. What else you have to find? You have to find an and bn values also. So we are discussing how to find Fourier series for discontinuous function. We covered first problem, now we are in second problem. Second problem, what it says, function is minus pi to 0 it is minus k, and 0 to pi it is k, therefore it is discontinuous function. To find Fourier series for discontinuous function, first of all you have to find a naught, an and bn value. In first slide, now we are able to find a naught value. A naught value is equal to 0 we got. Now let us go to the next. What you have to find? You need to find, now we got a naught, now you need to find an and bn values. Just to note down so that we can move on to the next slide of finding an and bn values. I already told you students, we are going to cover as many problems as we can in this 45 to 50 minutes class, because in COVID-19 situation many of the students are not having the material. So I am giving solutions of many problems in the video lesson itself. So solve the problems, then one or two homework, that's it. So take down this a naught value, then let us go to the an value as well. So what is an? An is equal to formula 1 by pi integration minus pi to pi f of x into cos nx dx. But how f of x is defined? F of x is defined as minus k from minus pi to 0 and k from 0 to pi. That's why now divide the integral into two parts. First one, minus pi to pi, it is divided into minus pi to 0 and 0 to pi. Why you have to divide the integral from partition into two parts? Why minus pi to 0 and 0 to pi? Why? Because the given function is discontinuous function. It is defined minus pi to 0 it is defined as minus k, and 0 to pi it is defined as k. That's why we have to divide the integral also, integral minus pi to pi, into two parts, that is minus pi to 0 and 0 to pi. In minus pi to 0 f of x value is minus k, and 0 to pi the f of x value is k. Substitute. Anyway, minus k and k both are constants, so they are outside of integral. Minus k by pi is outside integration of cos nx is sin nx by n, minus pi to 0 and 0 to pi, upper limit minus of lower limit. You know sin of n pi is 0 for all n, that is sin 0, sin pi, sin 2 pi, sin 3 pi, sin 4 pi, sin 5 pi, and so on. All are 0, therefore here sin 0 is 0, sin minus pi is 0, so 0 minus 0 is 0. So in both the parts, first part 0, second part 0, so total 0, k pi into an value also 0, it becomes an value is 0, that's it. So note it down so that we can move on to the next slide. We are able to find a naught, and now you are able to find an also. A naught we got 0, a naught value is 0. Now we got an also 0. Are you able to get it? The integral is from minus pi to pi, but f of x is defined minus pi to 0 it is defined one way, and 0 to pi it is defined in other way. So it is not the same value from minus pi to pi. That's why we have to divide the integral into two parts, minus pi to 0 and 0 to pi. And minus pi to 0 it is minus k, and 0 to pi it is k. Take constant k outside. Cos nx integration sin nx by n, upper limit minus lower limit, sin of n pi is 0, sin of 0 is 0, therefore you are getting an value is also 0. Just take it down so that we can move on to find bn. We find a naught value and now we are find an value. Now let us find bn also. Then substitute a naught, an and bn values in Fourier series so that you can able to find Fourier series for given discontinuous function. So this is what we got. We got a naught 0 and an also 0. A naught 0 and an 0. Are you able to find? Are you able to get it? An means you will get cos nx and bn means you will get sin nx. So now an completed. Now let us go to bn. Yes, let us go to the bn. So what is bn? Again bn is 1 by pi integration minus pi to pi f of x into sin nx. Same, f of x is not same on throughout the interval minus pi to pi. It is minus pi to 0, it is minus k, and 0 to pi it is k. Therefore divide the integral into two parts, minus pi to 0, 0 to pi. Minus pi to 0, f of x is minus k, and 0 to pi, f of x is k. Anyway, take k constant outside of integral k by pi. Sin x integration minus cos x. Sin nx integration minus cos nx by n, minus into minus plus. This is cos nx by n minus pi to 0. Sin nx integration minus cos nx by n from 0 to pi. Upper limit minus of lower limit. So cos 0 value is 1, whereas cos n pi value minus 1 all power of n. Why? Cos 0 is 1, cos pi is minus 1, cos 2 pi is 1, cos 3 pi is minus 1, cos 4 pi is 1, cos 5 pi is minus 1, cos 6 pi is 1, cos 7 pi is minus 1. Alternately plus 1 minus 1 plus 1 minus 1. That's why cos n pi is minus 1 whole power of n. Now substitute those formula. What we got? Bn is equal to k by pi 2 minus 2 into minus 1 whole power of n by n. If n is an even number, minus 1 whole power of n becomes 1, then 2 minus 2 becomes 0. Therefore, for even number, bn value is 0, and for odd number, bn value is 4k pi by pi. Too many lines. Let us erase them. Are you able to get it? Are you able to get it, the bn value? How you are able to find bn value? Cos n pi value is minus 1 whole power of n. Now after coming this here, what I am doing? Put n value 0 or 2 or 4 or 6 or 8 or 10, any even. If you take even, then it becomes, this becomes 1, this value becomes 1. 2 minus 2 into 1, 2. 2 minus 2 becomes 0. So for even value it is 0. And for odd value, n is odd, then minus 1 whole power of odd means it becomes minus. It becomes minus 1. When it is minus 1, minus 2 into minus 1, it is plus 2. 2 plus 2, 4. 4k by n pi when n is odd. So for all even numbers, it is 0. For only odd numbers, we have to take it as 4k pi by 4k by n pi, where 4k by pi is constant outside, a naught value 0, an value 0. In bn, 4k by pi constant outside, only 1 by n into sin nx. For n is equal to 1 sin x. And even numbers it is 0, only odd numbers 1, 3, 5, 7, like that. Sin x plus 1 by 3 into sin 3x plus 1 by 5 into sin 5x, and so on. After substituting this a naught, an and bn values, we got Fourier series f of x is equal to 4k by pi sin x plus 1 by 3 sin 3x plus 1 by 5 sin 5x, and so on. This is bn value and Fourier series. Take it down. Are you able to get it? Cos n pi is minus 1 whole power of n, whereas sin n pi is always 0. So a naught value 0 we got, bn a n value 0, bn value also for n even it is 0, only for n odd then it is 4k by n pi. Substitute a naught, a n and bn values in a Fourier series to get Fourier series f of x is equal to 4k by pi sin x plus 1 by 3 sin 3x plus 1 by 5 sin 5x plus 1 by 7 sin 7x and so on. This is the Fourier series we got for discontinuous function. This is the second problem we did. Let us go to the third problem of discontinuous functions. Find the Fourier series expansion for f of x if f of x is equal to 0, minus pi to 0 and pi x by 4 from 0 to pi. Take down the problem. Let us do the problem, third problem on discontinuous functions. So we are able to cover 20 minutes. So another 20 minutes left. Now let us go to the third problem. Find the Fourier series expansion where f of x is equal to 0 if x is from minus pi to 0 and pi x by 4 if x is from 0 to pi. So from minus pi to 0 it is 0 and 0 to pi it is pi x by 4. So left side of 0 it is 0 and right side of the 0 it is pi x by 4. Therefore such a function is a discontinuous function. For this discontinuous functions now you have to find Fourier series. So Fourier series, what is a Fourier series? F of x is equal to a naught by 2 plus sigma a n into cos n x plus sigma b n into sin n x. Now here a naught, a n and b n are Fourier coefficients. You can find these a naught, a n, b n values by using Euler's formulae. Integral formulas are called Euler's formulae. Very first class I told you. What is a naught? A naught is 1 by pi integration minus pi to pi f of x into dx, whereas a n is 1 by pi integration minus pi to pi f of x into cos n x. For a n you will get cos n x, for b n you will get sin nx. So what is bn value? 1 by pi integration minus pi to pi f of x into sin nx. These are the formulas of a naught, a n and bn. Now you need to find these a naught, a n and bn values. First of all let us go for a naught value. What is a naught? A naught is equal to 1 by pi integration minus pi to pi f of x into dx. This is a naught. But function f of x have not same on minus pi to pi. It is minus pi to 0 it is 0 and 0 to pi it is pi x by 4. So you have to divide the integral minus pi to pi into two parts, that is minus pi to 0 and 0 to pi. So integration is divided into two parts, 1 by pi integration minus pi to 0 plus integration 0 to pi. In minus pi to 0 the value is 0 and in 0 to pi the value is pi x by 4. So this is 0 no more, because 0 into something 0. Now only the second part you have to find 0 to pi x by 4 into dx. Pi by 4 constant and pi cancel also. So x integration x square by 2, 4 by 4 into 2 8. Outside you have to apply upper limit minus lower limit for x square, that is pi square minus 0 square. 0 square is 0, therefore pi square minus 0 is pi square. So what is a naught value? A naught value is pi square by 8. So now we are able to find a naught. What we need to find now? A naught, a n and bn values. So here we got a naught is equal to pi square by 8. Now let us find a n and bn also. Note down this problem and a naught values so that you can go on. Are you getting what are discontinuous functions? So they are throughout the interval they do not have the same value. Here minus pi to 0 it is 0, and 0 to pi it is pi x by 4. So such a functions are discontinuous functions. For these functions, how to find Fourier series? Fourier series same formula, but integration is divided into two parts. So in the formulas you got minus pi to pi integration. Now minus pi to pi integration is divided into integration minus pi to 0 plus integration 0 to pi. So we need to divide the single integral into two integrals in case of discontinuous functions. Another 15 minutes to go. Here we are able to find a naught. Now let us go for an. What is an? What is an formula? Can you recollect what is an formula? Yes. An is 1 by pi integration minus pi to pi f of x into cos nx. But already you know f of x is not same throughout minus pi to pi. It is the value from minus pi to 0, the value of f of x is 0, and 0 to pi the value of f of x is pi x by 4. That's why you have to divide the single integral minus pi to pi into two integrals, minus pi to 0 and 0 to pi. In minus pi to 0, you have at place of f of x you have to write 0, and in 0 to pi at place of f of x you have to write pi x by 4. This is what we do in discontinuous functions. Only one change from Fourier series of continuous functions to Fourier series of discontinuous function. What is that? We have to divide the integrals, because throughout the integral the function value is not same. That's why we need to divide the integral as it is defined for a discontinuous function. So you have to divide the integral into minus pi to 0 and 0 to pi. So this is what you are doing, minus pi to 0 and 0 to pi. In minus pi to 0 you are writing 0, and 0 to pi you are writing pi x by 4. So this integral value becomes 0, only you have to take the second one. 1 by pi constant, pi by 4 constant outside, pi and pi cancel. Now integration of x into cos nx. X into cos nx, you have to go for product rule, that is Bernoulli rule. For x algebraic function it is a first, and cos nx trigonometric function after algebraic as Fourier rule isolate. In isolate root, a algebraic first and t trigonometric second. So first function is x and second function is cos nx. X derivative 1 and 1 derivative 0. Cos nx integration sin nx by n, sin nx by n integration minus cos nx by n square, cross multiply, plus and minus. So what we got, it is 1 by 4 into x into sin x by n plus cos nx by n square from 0 to pi. So you know cos sin 0, sin pi, sin 2 pi, sin 3 pi, sin 4 pi, sin 5 pi, all values are zeros. Therefore, here sin x from upper limit and lower limit, the sin x value is 0. Only you have to apply on cos nx by n. Cos n pi it is minus 1 all power of n, and cos 0 it is 1. Therefore, the value becomes for cos nx it is, this is 0, and cos n pi minus 1 all power of n, cos 0 1. Therefore an is 1 by 4 into minus 1 all power of n minus 1 by n square. This is, we got an. We got a naught. Now you got an. Now let us find bn, then substitute in Fourier series to get the answer. Another 10 minutes to go. Or can you note down this? Let us move on. So what we got? We got a naught. We got a naught is equal to pi square by 8 and an also. We are able to find a naught and an values for this are able to get it discontinuous function. Why? Minus pi to 0 it is 0 and 0 to pi it is pi x by 4. So this is a discontinuous function. For discontinuous function, same formula of Fourier series, only integral is divided into two parts. A single integral minus pi to pi is divided into minus pi to 0 and 0 to pi. As it is defined in, we have to divide the integral. That's it. Are you able to get it? A naught pi square by 8 and an 1 by 4 minus 1 whole power of n minus 1 by n square. Okay, I will repeat for you Bernoulli rule. Okay, Bernoulli rule, you see what you are having, x into cos nx, pi by 4 constant outside. This is a constant you can take outside and remaining is x into cos nx. Eilert rule. Highlight. A means algebraic third letter, T means trigonometric fourth letter. So third letter is first, fourth letter is second, so x is the first, cos nx is second. X is algebraic function, cos nx is trigonometric function. Therefore, as for Eilert rule, x is a first function, cos nx is a second function. For x you need to find derivatives, and for cos nx you have to find integrals. X derivative 1, 1 derivative 0, cos nx integration sin nx by n, sin nx by integration minus cos nx by n square plus minus cos multiply, you are able to get x into sin nx by n plus cos nx by n square, sin 0, sin pi, sin 2 pi, all are 0. Therefore, the first term is 0. Only second term, cos n pi is minus 1 and cos 0 is 1. Hence, you are able to get an value 1 by pi, 1 by 4 into minus 1 whole power of n minus 1 by n square. So, this is an value. Now, let us go to the bn also. What is the bn? Bn is equal to 1 by pi integration minus pi to pi f of x into sin nx dx. Similar to that, similar to a naught and an, here also you have to divide single integral minus pi to pi into two parts, minus pi to 0 and 0 to pi. Sorry for that. So, minus pi to pi integration can be divided into two parts, minus pi to 0 and 0 to pi. In minus pi to 0, the function value is 0, and in 0 to pi, the function value is pi x by 4. So, the first integral is 0, you have to deal with only second integral. So, pi by 4 constant outside, and now you have to use Bernoulli rule, x into sin nx. As in an we are able to find it out. X is an algebraic function, sin nx is a trigonometric function. As for Eilert, x algebraic function first, sin nx trigonometric function second. Therefore, x is a first function, sin nx is a second function. Now, in a Bernoulli rule, find the derivatives of x and integrals of sin nx. Derivative of x is 1 and 1 derivative is 0. And derivative of sin nx is minus cos nx by nx. Further integration minus sin nx by n square, cross multiply, you are able to get this minus x into cos nx by n plus sin nx by n from 0 to pi. Upper limit minus of lower limit. Sin value, sin n pi 0, the second term becomes 0. Only for first term you have to apply upper limit minus of lower limit. Cos n pi is minus 1 whole power of n. Therefore, this is 0. Lower limit 0 into something 0. So, this also becomes 0. So, what is answer? Bn is equal to pi into minus 1 whole power of n plus 1 by 4n. Already power n we are having into minus. Therefore, it is minus 1 whole power of n plus 1. So, this is an value. Bn value. What is Bn? We got pi into minus 1 whole power of n plus 1 by 4n. Are you able to get it? We already having minus 1 whole power of n into minus means minus 1 whole power of n plus 1. Take down so that we can go on to the next. We are able to find a naught, an and bn. Now let us substitute all these values into the Fourier series, that's so that we can find Fourier series for this discontinuous function. let us erase all, let us see. So take it down so that we can go to the next slide. We are using Bernoulli rule here. So until this, what we are able to find it is, this is a question, a discontinuous function is given. First of all, we find a naught is equal to, we got pi squared by 8. Secondly, we find an, that is 1 by 4 into minus 1 whole power of n minus 1 by n square. And next we find bn is equal to pi into minus 1 whole power of n plus 1 by 4n. We got a naught, an and bn values. Now let us substitute these values in Fourier series in order to find Fourier series for given discontinuous function. So take it down so that we can move on. What is the time? Okay. As for the time, it is 40 plus minutes. So I think we are unable to cover one more problem. Let us end with this problem. Now substitute a naught, an and bn values in the Fourier series. Okay. Take it down so that we can move. Now a naught, an, bn values we are able to find. Now substitute in Fourier series. This is where we are substituting f of x is equal to 1 by 2 into a naught. A naught is pi squared by 8 plus 1 by 4 sigma minus 1 whole power of n minus 1 by n square into cos n x, pi by 4 constant, sigma minus 1 whole power of n plus 1 by n sin n x. Sigma means here excuse me, sigma means sigma n is equal to 1 to infinity. You have to substitute n is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4 and so on for both, for the an term and bn term. Here you have to substitute and here also you have to substitute n is equal to 1 to infinity. For n is equal to 1, n is equal to 2, n is equal to 4, n is equal to 6. For evens it becomes 0 and only for odds you will get and for n is equal to 1, 2, 3, if you substitute you get this. So what is a Fourier series at last for this discontinuous function? What is a Fourier series? It is pi squared by 16 minus 1 by 2 into cos x plus 1 by 3 square cos 3x plus 1 by 5 square cos 5x plus 1 by 7 square cos 7x. Only odd terms you will get. For all even terms it becomes 0. And what is bn term? Plus pi by 4 into sin x minus 1 by 2 into sin 2x plus 1 by 3 into sin 3x minus 1 by 4 into sin 4x plus 1 by 5 into sin 5x, alternately plus and minus you will get. So this is a Fourier series for given discontinuous functions. We are able to cover how many problems? How many we covered here? We covered three problems on Fourier series of discontinuous functions. So it is almost all 40 to 45 minutes. So here we can end. No time to cover another problem. So I would like to end here. So what is the point we learned here? In case of discontinuous function, we have to divide the single integral as number of integrals as the discontinuous function as it is defined. So how it is defined? In the same way we have to divide the single integral into number of integrals and do the integration and substitute a naught, an and bn values in a Fourier series formula so that you can expand given discontinuous function in a Fourier series. So this is what we covered in this class. What is that? Fourier series of discontinuous functions. How will be the discontinuous functions and how can we find Fourier series for discontinuous functions? That's what we did here. We given solutions for 3 problems in a single class. Now shall I give homework? Yes, let us go to the homework now. So homework I will give for you. So homework is this: discontinuous functions, expand f of x. How it is defined? F of x minus pi to 0 it is 0 and 0 to pi it is x. To left side of 0 the value is 0 and right side of 0 the value of function f of x is x. That's why it is discontinuous function. Now you have to find Fourier series for this discontinuous functions. What is this? You have to write a Fourier series which involves a0, an and bn value. So integration minus pi to pi is divided into two parts, that is minus pi to 0 and 0 to pi. And what is the second problem? Just very similar to this. F of x is x if x is in between minus pi to 0, and f of x is 0 if x is in between 0 to pi. So the function is minus pi to 0 it is x, and 0 to pi it is 0. It is a discontinuous function. So write a Fourier series, find a0, an, bn. In a0, an, bn we have a integration minus pi to pi. Now divide integration minus pi to pi into two integrals, integration minus pi to 0 plus integration 0 to pi. That is only one point in how to find Fourier series in discontinuous functions. Since it is throughout the interval, the discontinuous function do not have the same value. That's why in finding a0, an, bn values, divide the integration into two parts and do the problem. That's it. So this is a homework. So first of all, practice all those three problems that we covered on discontinuous functions. Finding Fourier series for discontinuous functions, we covered three problems in this class. So first of all, practice those three problems. So remember, what is the note that you have to remember is sin n pi value is always 0, sin cos 2 n pi is 1, and cos n pi is minus 1 whole power of n. These things you have to remember and practice the problems. After practicing problems, then do the homework problems. So this is here I will like to end the class. So if you have any queries, you can mail me at naresh.debbadi@gmail.com. Also, you can post in Google Classroom also. So practice the three problems we are solved here, then do the homework problem and post the homework problems in Google Classroom, or mail me for any queries. And if you are able to post the homework, I can respond you, I can verify your homework, and I can able to respond you. In next class, what we covered at here previous class and this class, we covered the Fourier series in different intervals, and finding a0, an and bn values, and finding Fourier series for different function. And in this class, what we covered? In this class we covered finding Fourier series for discontinuous functions. So that's what we covered. In next class, we are going to find Fourier series for even function and Fourier series for odd functions in the next class. Until then, bye. Thank you guys. Thank you very much. Having a patience for at about 45 minutes. So thank you very much guys. Thank you.